All right, so I think this is recording. Let's take a look here at number 5. They give us a polynomial function. They want us to factor it, and they've done part of the work for us, and they've presented that information in the body of a table. So zeros are just another word for roots, which is another word for x-intercepts. If x equals 0, x equals 2 is a 0, then when we do synthetic division with 2, the remainder theorem says that we'll get a 0. So let's make sure that this is in standard form, which means that the exponent should be in descending order, 5, 4, 3, 2, 1, and the constant. So everything is set up and ready to go. We just have to be very careful to not make any arithmetic errors. Or just accidentally copy down the wrong values, which I often do. All right, so now the pattern is synthetic division. The first value comes down. If this number is written below this line, you multiply it by the number that's in the box up here, the 2, and write that underneath the next number and add. And so then you just keep repeating that. If we take away 36, yeah. All right. So with the multiplicity of 3, we can do this 2 more times. All right. So there. Now let's shrink this up so I can do a little bit of work. So what we have here now is that we can rewrite this p of x as x minus 2 quantity cubed, because the multiplicity was 3, and now this is a quadratic. And we can factor it, and normally your choice is the x method. When the leading coefficient is different than 1, you have to come down here and make a table, or maybe you say chart it. I don't know what you... It seems like different students call it different things. All right, along one diagonal, I have 3x squared and 3x squared. And here, this is what I want to be 4. The first and last term of my trinomial, and then the 2 values that I found in my x, and it doesn't matter the order that I put them in this table, in this chart. So horizontally here we have a 1, and here both of these values have a common factor of 4, and then horizontally here we have a 3x that's common, and here we just have an x that's common. So that means that we can factor this to x minus 2 raised to the 3rd power, 3x plus 1, and x plus 4. So if we set this equal to 0, that's how they got the x equals 2, because 2 minus 2 is 0. And here if you subtract 1, and then divide by 3, and that has a multiplicity of 1, so that's a cross. And then here, if you just subtract 4, set it equal to 0 and subtract 4. So we're able to complete the table, and we have the polynomial written in that is completely factored. We say it's in factored form. All right, so I hope that helps, and I'll talk to you later. Bye.